All right, class, in our next volume video, we're going to look at the volume of cones. Now, the volume of cone is related to the volume of a cylinder. What I want you to notice is the only thing that is different is the fraction that is out front. And so when we visualize a cone, perhaps it's fair to maybe do something like this and try to visualize that cone around. I hope that drawing helps you to visualize the part of the cylinder that we're looking at. It's like we've shaved off all the way around, but at an angle going towards the center of the top. Again, I hope that makes sense, but all of that is gone. And what we're asking you to do is to trust me. What I'm asking you to do is to trust me that the volume of a cone is 1/3 the volume of a cylinder. And the purpose of these videos is not to try to prove all of these formulas, but sometimes, well, as I've said in class, we just need to trust it. And so we know that if we solve for the volume of a cylinder, this is the volume of a cylinder, we're simply going to multiply it by 1/3 to get the volume of a cone. So let's look at an example. Let's say I have a cone, with a radius of 3 inches and a height of 6 inches. Well, the volume of a cone is 1/3 pi r squared h. And so this whole unit is all about substitution. But it's also about how to execute this math. So it's going to be 1/3 pi. What's the radius? 3 inches. We're going to square that and then multiply it by the height. So let's do this. Let's keep working here. I'm going to show you a different way of writing this. What if we did this? 3 squared is 9. 9 times 6 is 54. So what I've done is I've just simply, let's see if we can draw this just a little different. It's almost like I've done this. I've just put some brackets around this whole problem, and I'm multiplying everything on the inside, which would technically be over 1, by 1/3. And so I'm hoping that you can see that that's where the 3 came from, this 3 right here. It's like there's a 1 out here. There's the 1 from the 1/3. Well, now I have 54 pi divided by 3. And 54 divided by 3 is 18. So my answer would be 18 pi inches cubed. That would be the volume of a cone with a radius of 3 inches and a height of 6 inches. It would be 18 pi cubic inches. Now, as I've said in previous videos, in my class, I'm perfectly fine with you leaving pi in the answer. But if you were to multiply it out, that would be 18 times 3.14 for the abbreviation of pi. And you would get approximately 56.5 cubic inches. So that is the basics of working with volume of a cone. As you can tell, it's the exact same as cylinder. You're just simply multiplying by 1/3. This part right here, actually doing something with that 1/3 can be the challenging part. So what I want you to do, I've given you a couple of practice problems. I encourage you to pause the video and give these a shot. All right, so we've given a radius of 14 feet and a height of 2 feet. We know our formula for the volume of a cone is 1/3 pi r squared times h. And so we're going to substitute 1/3. There's our pi. Our radius is 14 feet. Our height, we're going to square the radius. The height is 2 feet. All right, so as we work through this, we know we have, I'm going to put it all over 3 again, and that's going to be pi times, that's 196 square feet, times 2 feet. So let's move over just a little bit. 2 times 196 is 392. So 392 pi over 3, and that's going to be cubic feet. Now that still sounds a little bit odd. That's actually the most exact way to report this answer. But we could, if we wanted to go a little further, divide the 3 out, and you get 130.7 pi cubic feet. And so what I've shown you here is a problem that it doesn't work out to be these nice, perfect little numbers. And honestly, I'm doing that on purpose because as you move into high school math, you need to start getting used to decimals and fractions, such as this, that might not always look pretty. You've been too accustomed to numbers working out evenly, 12 divided by 4, oh, that gives me 3, and everything works out nice. And then when you see something that looks like this, or perhaps like this, it begins to trip you up. But remember, not everything works out evenly. And so one thing we can do, let me change back to the pen, is if we want to multiply pi out of this, now we're at approximately 410.5 cubic feet. And so those are all the same answer. This is the most exact answer because I have a fraction and I have pi. This is the next step. I've left pi in the answer, but you'll notice that 392 divided by 3 is not something that's even. And then I multiplied pi out. And so now on a quiz or a test and homework, you do not have to report all of those answers. Again, I'm fine staying right here with pi in the answer. But depending on your teacher and depending on what the question is asking, you may have to multiply pi out or move the fraction out as well into the form of a decimal. If you haven't already done so, go ahead and pause and try problem number 2. All right, well, that done, we know we want the volume of a cone that has a diameter of 10 millimeters and a height of 9. So again, our formula is volume equals 1/3 pi r squared times h. So that's going to be 1/3 pi times 5 millimeters. Now, that's going to be squared. The height is 9 millimeters, so we're just substituting. But notice it was diameter, but in our formula, we are looking for radius. Don't get caught by that. All right, and so 5 squared is 25. And then when we multiply that by 9, we're going to go ahead and go pi. 25 times 9 is 225. And all of that's going to be divided by 3. So the way you would actually write that is 225 pi, and that's going to be cubic millimeters. But we can divide the 3 out, and this one actually divides out very evenly. So we're going to have 75 pi cubic millimeters, if I can fit that in there. That is your most exact answer. However, if you wanted to multiply pi out, you would hit your pi button and multiply and get 235.6 cubic millimeters. And that, of course, would be approximate. All right, let's look down at one more problem. So I would encourage you here, notice there's a little difference. I'm asking you to solve for the radius, and I give you the volume. I would encourage you to think through this. Go ahead and give it a shot. Pause the video, give it a shot, and then come back. All right, so we know we're still dealing with a cone. And so our volume for the cone is V equals 1/3 pi r squared h. And now think substitution. What do we know? We know the volume, so it goes there. We know the height, so it goes there. And what are we left with? Radius. And remember, we have one equation with one unknown. It's gold. We can solve that. So 100 centimeters cubed equals 1/3 pi r squared times 5 centimeters. Now, there's a couple of options you have to solve this. One option would be this. I could multiply everything by 3 here. Now, what does that do? It gets rid of the fraction. Okay, so in this case, that would go to 300 centimeters cubed equals pi r squared times 5 centimeters. Now look, these are all multiplication. Everything here is connected by multiplication. So you don't multiply the 3 times the 1/3, the 3 times the pi, the 3 times the r squared, and the 3 times the 5. It's just on the outside. And so that's why you get rid of this fraction. Now, in a case like this, it's not too bad from here. I would say the simplest thing would be to divide by 5 centimeters. Go way up here. So when you divide everything by 5, you're going to end up with 60. Now, notice your units here. That's going to be centimeters squared equals pi r squared. And that's what you're wanting. Come back down here to the bottom. You're dividing centimeters cubed by centimeters. And so what happens when you divide common bases? You subtract their exponents. And so that would be 3 minus 1 and give you a 2. Now, the best way we have to solve this is we've got to get pi out of our answer. So we've got to divide everything by pi. Now, as you can tell, this begins to look a little bit ugly, but that's okay. The pi's are going to cancel here. So pi divided by pi is 1. And so that leaves us with r squared on this side. Now, here you're still going to end up with centimeters squared because the pi is unitless. But what's 60 divided by pi? And this is where it begins to get ugly. For our purposes, you could just say 19.1. Now remember this, we have a squared on this side. Well, how do we get rid of the r squared? Because we're looking for r, right? Aren't we looking for r? We're not looking for r squared. So we take the square root to get it back down to r. But what we do to one side, remember that golden rule of algebra? We have to do to both. And so this is where your calculator is going to become very handy. You're going to have 4.4 centimeters. That is going to be your radius, 4.4 centimeters. Why don't we do a little check here? Because these numbers are a little bit crazy. Now, if we use the numbers that I've written down, it's not going to check perfectly, but we should be able to get really close and verify what we've done. So we know that it's a cone, so it's 1/3 pi r squared h. So 1/3 pi, what's my radius? Well, I'm going to use 4.4, and I'm rounding, so that means I'm going to be off. And then we have 5 here as well. So when you look at your calculator, you end up with 4.4 squared is 19.36. Multiply that times 5 and you get 96.8. Divide that by 3 and you get 32 point, let's just say 3 pi. All right, well, multiply that by pi and you get 101.4. Now look, that's close, isn't it? And so it's just close. And as I said a couple of times, it's not going to be exact because when you divide 60 by pi, you actually get a much larger answer, a longer answer, I should say, than 19.1. And so this is just designed to check to get us close. So I know that these numbers, it's so much easier to see numbers that work out nice and round. But it doesn't change the math when the numbers get into these long decimals. And you need to start getting used to working with them, thinking through them, and really being okay with them. So yeah, I hope this makes sense. And let me know if you have any questions. Thanks.